In this section, we will explore the fundamental building blocks of container technology, such as Cgroups, namespaces, and capabilities. Unlike a virtual machine, Docker provides an isolated environment using the Linux kernel's built-in features such as namespaces, Cgroups, and union file system. By using these technologies, Docker can provide fine-grained control on who can talk to who and at what granularity. Namespaces help in isolating processes, file system, and other sources from other containers and the host. Cgroups help in limiting the resources a container can consume. Capabilities help in limiting operations that a container can perform. Docker creates a separate namespace for every container. Namespaces are at the core of Docker's isolation. Every container has its own set of processes, system mounts, users, kernel identifiers, and network resources. By default, one container cannot see the resources of other containers. Because of such isolation through namespaces, every container believes that is it the only existent system running on a machine. Docker creates the following namespaces to isolate a container to itself. The PID namespace to provide isolation between processes, the net namespace to provide isolation between network interfaces, the mount namespace to provide isolation between file system mounts. As an example to review the namespaces, let's try running two containers from an Alpine image named alp1 and alp2 that sleep for different duration. The first container, alp1, sleeps for 10,000 seconds. The second container, alp2, sleeps for 10,001 seconds. We can then find out the process ID of the sleep processes that are running inside the containers using Docker executing command. Docker exec helps in executing commands inside a running container. We can then find out the process ID of the sleep processes from the host machine using psaux, grep sleep. You'd notice that there are sleep processes that sleep for 10,000 seconds and 10,001 seconds respectively with different process IDs, but they are still on the host. When inside the container alp1 only sees its own sleep process that sleeps for 10,000 seconds. Similarly, when inside the container alp2 only sees its own sleep process that sleeps for 10,001 seconds. From the host machine, we can actually look at the namespace information by listing the contents of the /proc/pid /ns/directory. Start an Alpine container that sleeps for 1,000 seconds. Review the process ID of the sleep process from the host machine. Then list the contents of the /proc/pid /ns/directory to review the namespace information of the container process. Cgroups are control groups that help limit and control resources that a container can have access to. Cgroups uses additional utilities and features to limit resources like iptables for networking and TC or traffic control. You can enforce soft and hard limits. Soft limits are not generally enforced. When a process group hits its hard limits, OOM killer for that group triggers and kills necessary processes. Memory limits can be set on physical, kernel, and total memory that can be consumed. Cgroup limits are not enabled by default while running containers. The example presented here limits the memory the container can consume to 2 GB and sets a swap limit of 1 GB. From the host, we can run Docker stats with the container ID to find the memory limits for a container. Capabilities help us restrict activities that a root user can perform or add more permitted activities to a low-privileged user. Docker by default enables the 14 capabilities as presented here in this slide. The example here drops the netraw capability for an Alpine container. Once inside the container, when we try and ping google.com, we would get permission denied error. I hope you have enjoyed this lecture. Let's move on to the next lecture.